Taking Praxis Physics Content Knowledge 5266, Principles and Models of Matter and Energy? If so, this is the right video for you. My name is Tom. I am a retired teacher and test prep expert here at study.com, and I'm going to walk you through the test. So let's get started. All right, problem one. Which of the following best explains why atoms have quantized energy levels? So what I'm going to do is I'm going to eliminate some possibilities here. And first off, I see choice D. The energy levels in atoms are determined by the intensity of the surrounding light, and that is incorrect. Energy levels in atoms are determined by how far they are from the nucleus. So I'm going to eliminate choice D. Choice C, atoms can only absorb energy when they are heated to very high temperatures, while heating to high temperatures makes the molecules in the atoms move faster, so that does not explain quantized energy levels. Choice B, the nucleus of an atom can only release energy in whole number multiples of a fundamental unit. Again, does not explain quantized energy levels, and the correct answer here is A. Electrons can only occupy specific orbits with fixed energies around the nucleus, and energy levels are fixed and specific for each atom, and this was introduced by Bohr's law, and electrons can only move out of those fixed units if they lose or gain energy. So in this case here, the correct answer is A. All right, problem two. When comparing alpha particles, beta particles, and gamma rays, which of the following statements accurately describes a characteristic that distinguishes these types of radiation? All right, so let's eliminate some possibilities. So the first one I'm going to eliminate is choice A. Beta particles are positively charged, and actually beta particles are negatively charged. So we're going to eliminate choice A. Choice B, gamma rays have the least penetrating power, and that is false. Gamma rays have high penetrating power. They can pass through different types of material. So choice B is eliminated. C, alpha particles are the least massive form of radiation among the three, and that is incorrect. Alpha particles actually have more mass than beta and gamma particles. So the correct answer here would be choice D. Gamma rays are electromagnetic radiation, while alpha and beta particles are types of particulate radiation. And so gamma rays are electromagnetic radiation, kind of like X-rays and light, but with much higher energy levels. And alpha and beta are just particles with mass, so are types of particulate radiation. So the correct answer here would be D. All right, problem three. Which of the following scenarios accurately describes the relationship between the temperature of a gas and the average kinetic energy of its molecules? All right, so let's eliminate some possibilities here. And what we're looking for is a direct relationship. So the average kinetic energy of molecules is directly related to temperature. So any of the choices that don't have a direct relationship can be eliminated. So for example, choice A could be eliminated. It says lowering the temperature of a gas increases the average kinetic energy of the molecules. Actually, it would decrease the kinetic energy. So choice A is eliminated. Choice B can be eliminated. It says its average kinetic energy of gas molecule is unaffected by changes in temperature, and that is not true. It is affected. Choice C, at absolute zero, gas molecules have their maximum kinetic energy. They actually have no kinetic energy at absolute zero. So choice C is eliminated. So in this case here, the only one that shows a direct relationship is choice D. An increase in the gas temperature results in an increase in the average kinetic energy of its molecules. So choice D is the correct answer. All right, problem four. In an insulated container, a hot metal block is placed into colder water until thermal equilibrium is reached. Which of the following statements best describes the conservation of energy in this process? All right, so let's eliminate some possibilities here. So the first choice, A, is out. The total energy of the system increases as the metal block cools and the water warms up. This does not represent conservation of energy. We can't have an increase in the total what we're going to have is a decrease in the energy of the metal block and an increase in the temperature or the energy of the water. So choice A is out. Choice B is eliminated. It says the temperature of the water decreases as it transfers energy to the metal block. Actually, the water is going to increase in temperature from the hot metal block being placed in there. So choice B is eliminated. Choice D, the metal block gains heat as the water's temperature increases. So that has both of them gaining energy, which is incorrect for conservation of energy. And the correct answer is C. Energy is neither created nor destroyed. The heat lost by the metal block equals the heat gained by the water. And this does best describe conservation of energy. So what's going to happen is the hot metal block is going to reduce its energy and the water is going to increase its energy. The net gain is not going to be different. We're going to wind up at thermal equilibrium, and that best describes the conservation of energy. All right, that concludes our walkthrough of Praxis Physics Content Knowledge 5266, Principles and Models of Matter and Energy. Thanks for watching, and please like and subscribe.